Hello, this is Mission Control. It has taken far too many years for the most powerful space telescope in history, the James Webb, to finally show us the first full-color images, which are the following: the Carina Nebula, the Deep Field, the Southern Ring Nebula, Stephan Quintet, and the spectrum of an exoplanet where the distinct signature of water has been detected. Do you want to know all the details about these images? Then come on in, I'll tell you all about it. 3, 2, 1, we are go! It all started on July 11th, when Joe Biden decided to reveal the first image in history from the James Webb, in an event with certain improvisation hues. We will not dive into what got into Biden to anticipate NASA's long-scheduled event, but rather focus on this very first picture, this first full-color picture of the James Webb. So what are we seeing? Well, we are seeing a beautiful and very distant cluster of galaxies, and that alone makes this image worthwhile. But there is more, much more. Do you see these bent galaxies here? They are all over the image and form something like concentric circles. Why? Are these galaxies really bent? Well, no. What is happening is that we are passing through a gravitational lens, a large magnifying glass of millions of light years in diameter that has been created due to the enormous gravity of all those galaxies gathered in that space segment. This causes gravity to distort the fabric of space-time around that galaxy cluster. And what happens then? Well, behind that cluster there are more galaxies, many more galaxies, some of them at the very ends of the universe. And as you know, since looking far away in space means looking far away in time, something very curious happens. Do you know how old the universe is? 13,700 million years old. And do you know how old those galaxies are? 13,200 million years old. That is, they arose shortly after the Big Bang. If only we could capture the light from those distant galaxies in this picture. Oh wait! We've already caught it! All the distorted galaxies you see in the image are the oldest galaxies in the universe, and the James Webb has just revealed them to us with unprecedented sharpness. What happened? The light from those far galaxies, those that look bent behind the galaxy cluster, has passed through our gravitational lens and reached us amplified in the photo, with the James Webb being able to capture it with unparalleled sharpness. The Hubble telescope already tried to get a picture of them, but Webb's image, in comparison, makes us realize the enormous potential of this telescope. The following image was shown at the long-scheduled July 12th event, a date that will go down in the history of astronomy. It is from the Southern Ring Planetary Nebula, one of the images I most wanted to see. We were shown two pictures, taken by different devices aboard the James Webb, working at distinct infrared wavelengths. This nebula is not formed by planets or anything like that. You won't see any planets here. It is instead the corpse of a star, a white dwarf. And no, it's not the one that can be seen in the center. That's actually a much younger star, which will eventually end up just like this other one. However, the glow of this very young and bright star hides the white dwarf from us. But here, in the same image taken by the Hubble telescope, we can see it. And what happened to that star is that it reached the end of its life. It had exhausted all the fuel it was capable of fusing and has collapsed under its own gravity, ejecting its outer layers outward. The remnant core is no longer capable of fusing, it is dead, but it is still very hot. And little by little, in a process that will last millions of years, it will eventually cool down so as to stop shining forever, becoming a black dwarf. Then, we were shown this other image, Stephan Quintet, also photographed at the time by the Hubble telescope. Here, I must admit that the Hubble photograph looks perhaps a little more spectacular for the general public, but certainly the James Webb one stands out for the enormous amount of detail that can be seen in the different shots at varying wavelengths. Here, we're actually looking at 5 galaxies, 4 of which are gravitationally bound to each other, which makes them look as if they are in the middle of a cosmic dance. Regarding the exoplanet, I am afraid that some might have been disappointed. That is because the James Webb is not able to photograph the exoplanet, but it can instead analyze its atmosphere, which is exactly what it did. How? By analyzing the light that reaches it from its star when the planet passes in front of it. By doing this, the James Webb has captured the distinctive signature of water, along with evidence of clouds and haze in the atmosphere surrounding this giant planet of hot, puffy gas orbiting a distant star similar to our Sun. And before we move on to arguably the most spectacular image, let me remind you to subscribe to the channel if you want to stay up to date on all things related to our space exploration. Okay, the image, the most spectacular of all. Just a heads up, if you haven't seen it out there yet, hold on tight, it's this one. Now you know why NASA saved it for last. It is simply spectacular. This is the Carina Nebula, one of the largest nebula in the sky. The level of detail in the image is overwhelming, and I could literally spend hours analyzing each of its pixels. This is one of those iconic photographs that will remain in the collective imaginary forever. And if you still haven't thought of setting it as your wallpaper, I think you're overdue. Which brings me to the next question. How do I download the images? Here below, in the video description, I'll leave the link so you can download them all. And I am also going to leave another super interesting link. It is an app developed by a Twitter user where we can compare the images taken by the James Webb with those taken by the Hubble telescope back in its day. And this way, you can realize how powerful this telescope is, the enormous difference between the pictures, and all that we will be able to discover with it. If you have any questions, don't forget to write them in the comment section, and I will try to answer as many as physically possible. Nothing else from Mission Control. Thank you very much for watching the video, and see you in the next one. Bye bye!